Hi everyone, good to see you. Thanks very much for coming along. I'm going to be talking about using WireMock, the tool that we work on, but using it with http4k specifically, which is kind of the Kotlin angle on the talk. Who am I? I'm Rob Elliot. I've been working on the JVM for 23 years now, on and off, so I've plenty of experience of various different web frameworks. It's nearly all been web-based. I've been doing Kotlin for about 5 years now. Started off for Expedia and just felt like having gone through Groovy and Scala, it was nice. It felt like it was coming home. It's the one that actually worked. Been working on WireMock since 2013. Probably the most significant thing I've done on WireMock was some of the TLS proxying behavior that allows you to use it just as a forward proxy and record whilst navigating amongst lots of different TLS-based apps. And I joined WireMock Cloud. Well, I joined its precursor back in January 2022, and we launched as a new startup. I think officially it was May 2022 that we were formed as WireMock Inc. And yeah, if you want to find me on social media, it's not terribly interesting, but if you want to, they are there. So what's WireMock? This is what it says on the front page. It's a popular open source tool for API mock testing. So I think of it as it's your little HTTP server that you can just spin up and you can program it at runtime. And then you can also verify what's actually happened in terms of the traffic that's gone to it. I think its sweet spot is when you bring in, say I don't know, you're talking to some third-party thing, and they've provided you with their own little client, and you've got no idea what it does. It's given you an API that you can call, but what that actually means, you don't know, and you're not sure. So, and you're not even sure how to get in there and inject an HTTP client or anything like that. WireMock's just perfect there, because so long as you can pass in a base URL, you can pass in WireMock as the base URL, and you can start finding out what it's actually doing, what HTTP traffic is it sending, and then you can start stubbing that out. So perhaps if you're talking to Stripe, for instance, you probably don't want to be talking to Stripe's dev platform in your unit tests, because suddenly Stripe goes down and bang, your tests are failing, and also you've got all the latency of talking to them. And do they allow you to set up all the scenarios you need to test? Possibly not. So you could spin up a WireMock, and you can then stub out all the things you care about, and you can test all the error cases and things like that. It's also really good if you're just using an HTTP. So if you're like me, you've been knocking around for decades, then you've used a lot of different HTTP clients, and they're all slightly different. And sometimes they have layers of filter layers which are adding in headers or removing headers, or perhaps they're following redirects, or perhaps they aren't following redirects, and you're not sure. And being able to actually go, no, I know this bit I can control. I know what's going on, what HTTP looks like. And by spinning up my own server, I've got control. And I can start finding out exactly what's going on and testing for exactly what I'm interested in doing. The ways to use WireMock. The most basic is you can use WireMock standalone. So you can just pull it down, the standalone jar. You can run the jar, and you'll get this. And it's listening on port 8080, so you can then communicate with it. It's got an admin API which you can use to program it, and then you can call the actual stubs that you've set up. Second way, unsurprisingly, it's been Dockerized. You can use it direct, obviously. So you can just do a Docker run of WireMock 3.10, which is the latest release. And again, you'll get exactly what you saw before because you're running it via Docker, so you would. That saves you having the JVM or worrying about which JVM you're going to use or anything like that. You can also use it via test containers. I don't know if any of you have used test containers. We've got specific WireMock test container modules for Java, Go, and Python. So you're not restricted to just using it on the JVM. I'm going to skip over this fairly quickly because if we're using Kotlin server-side, we're on the JVM, so there's actually not a huge amount of value. There is some value. One thing that it can do for you is insulate you from class low to hell. So WireMock has quite a lot of dependencies. There's a standalone jar which shades most of those dependencies, but sometimes where you've got annotation behavior or things like that, or if you get involved in SLF4J and logging, you can get some behavior where the shading can itself be a bit of a problem. So if you get yourself in a complete mess, then you can always go to using a test container one, and then it's in a separate process. Don't need to worry about class loading. But generally speaking, you don't need it on the JVM. But having it for Go and Python is nice. And we've now got JavaScript and Python client libraries as well, so you don't have to just speak curl. You don't have to speak pure HTTP to set it up. Finally, you can run it embedded, and that's where we're going to be talking most of today. And there's two ways of running it embedded, and the most common way is to run it over the wire. So I'm going to go through now and give an example of setting up and running a test suite with WireMock, where you're talking to WireMock over the wire. Our stack's going to be http4k as the HTTP client. We're going to use Cotest as the testing tool. Are people familiar with Cotest? Yeah, it's nice and easy. It's like JUnit, but I think easier because you just call functions to register your tests instead of having to literal annotations around and find out what happens at runtime. And obviously, we've got WireMock as the HTTP server. So the first thing we're going to do is set up the test. So what we're testing is we're going to pretend that we're writing an email client for talking to SendGrid to send emails. And yet, I know SMTP exists, but everything's over HTTP now. It's going to be simplified. It's not what SendGrid actually do. It's just simplified down. But the basic principle, we want to make an HTTP request to send an email. So the first thing that we're going to do in our test is we're going to create a WireMock server. We're going to pass it the options to say that it needs a dynamic port. That's always a good idea. It means that you can run your tests in parallel. You can have pause one test with a breakpoint and still run another one because they're all going to run on separate ports. We're going to use a listener for Cotest. Cotest actually has a WireMock module that you can use. And so you can then just go per spec, SendGrid mock. And what that's going to do is start the WireMock server at the start of the spec and stop it at the end. That's all it's going to do. And therefore, which means that we have to do something else ourselves, which is to say that before each test, we want to reset the requests. The reason is that with WireMock, you verify what happened, or you can, if you choose to, verify what happened. But starting and stopping the server isn't going to clear out the history of what requests have happened. So we need to do that between each test. And then we're going to start setting it up. And I'm going to do this in the before spec because what I'm actually going to do, rather than setting it up per test, I want to set up a kind of fake version of SendGrid entirely. So I'm going to say, okay, I'm going to create a stub by using given that on the SendGrid mock. I'm going to say, given that you get a post for that path, then I'd like you to return a response with a status of 200 and with a body of status sent. So we're just stubbing out the happy path here. We're saying that so long as you send me any post, that URL is going to get back a 200 with this status. So let's define the interface that we're actually going to test. So we've got a SendGrid email client. It's going to need a few things. It's going to need an actual thing to do the HTTP. So we're going to use http4k HTTP handler. That's just a type alias for a function that goes from a request to a response, which is the really nice aspect of http4k. It's very simple. It just observes that HTTP is fundamentally a function, takes a request, returns a response, and models it that way, which is what's going to let us do some quite cool stuff later on. We're going to need a base URL to know where we're talking to. We need an API key because you do, in order to send emails, you've got to have something proving who you are. And we're going to say who we are. So whenever we use this client, it's always going to be from the same address. And we're going to then define what the actual function you can call on this thing is. Well, you can send an email, and you need to tell them who you're sending it to, what the subject is, and what the body is. I think that's. I went for email on the basis we all hopefully know what an email looks like. So now let's write the test. So we're using string spec, which is a Cotest flavor, where you can it's got an extension function on string to take a function that actually defines the test. So it's the lightest of the possible Cotest implementations. So we're going to try successfully sending a valid email. And we're going to say, given that we've got a sender, and we've got a recipient, and we're going to create our SendGrid email client. We're going to pass it the Apache HTTP client. This is an out-of-the-box http4k client that just delegates down to the Apache Commons client. Give it a base URL, which we're going to retrieve from the SendGrid mock. So the moment the SendGrid mock starts up, it picks up that dynamic port, and then it makes the whole thing, so you don't have to stick together the URL. You can just pull it out. We'll give a made-up API key, and we'll say that who the sender is. Okay, so now that we're going to actually make a call, so we'll call send email with the recipient, subject, and body. And finally, we're going to check what happened. So we're going to then ask SendGrid, did you get the request we're expecting? So we're checking, was there a post requested for the URL we wanted with the request body equal to JSON, and we can just dump the JSON fragment in there. The nice thing about the equals to JSON matcher is that obviously you don't have to worry about white space, you don't have to worry about key ordering, it's just going to match it as to whether it is object equals effectively. And then we're going to watch it fail because we haven't actually written anything yet, and you never trust a test you haven't seen fail. So we'll run our Gradle test, and we get back a test failed because we've got a verification exception. And if we have a look at what that verification exception looks like, it's telling us, okay, expect at least one request matching that URL, that method, and the equal to JSON we said, but it didn't get any requests at all. So it's not able, it's just telling us nothing happened, unsurprisingly. So let's make it pass. So it's a very simple one to write. We're going to have a data class. I'm not showing you the data class. We're going to say there's a data class called email with a to, from, subject, and content. Then we're going to new up an http4k request with the post method and the appropriate URL. And we're just going to set the body being, we'll serialize the email to JSON. As it happens, I'm using Jackson, but could be anything that will turn a data class into JSON for you. And then we just call client.invoke request because the client, as you recall, is just a function. So I put the invoke in there just because it feels a bit weird doing client brackets request, but it could be. So if we run it now, then you get a rather less noisy build successful because it's all working. So good. And then just to make things slightly more interesting, I wanted to show a bit more of what WireMock can do in terms of being more realistic. So if you recall, when we set up that 200 stub, we literally said, it doesn't matter what you post to this endpoint, you're getting back 200, okay. So we can make things a bit more strict than that. So first thing is we're going to declare there's actually a valid API key, and it's the only one that we're going to accept. And so then we can just set up a new stub, and we're going to set this up saying that it's going to match any method for any URLs. This is a really broad stub. And it's going to say, it's also going to match any request then which has a header of authorization, but which is not equal to the valid API key. So what we're doing here is we're actually setting up a negative stub. And we're going to say that anything that doesn't have the appropriate API key is going to return a response with a 401 to say, no, you can't have it because you don't have a valid API key. And yeah, we'll stick in an error in there. And we're going to put it at priority 2. So WireMock has a notion of priorities of stubs. And essentially what it does is it goes across them. So lower number is higher priority. So priority 1 is the highest priority. It's going to cross all the stubs at a particular priority, trying to see if any of them match. And if any of them do, it'll return that and it won't go further down. So, and the default priority is 5. So by making this priority 2, what we're saying is check this first. And if anybody sends anything which doesn't have the authorization header, it's going to get bounced out straight away because this one will match. And let's set up another rule, which is another, I find this really useful. I love this bit because it saves you so much writing. We can say, still looking at our particular one, so if we do a post for our particular URL, but we're going to say that this time we're interested in request bodies that don't match a particular JSON schema. So effectively, so we're going to say, okay, the JSON schema we expect to get an object, we expect it to have properties 2, which is as format email, from with format email, and a subject of type string. And we say that anything that does not match that should return a response with status 400 with body invalid request format. And again, we set it at a slightly higher priority than our happy case stub. So the point here is that we're going to basically blow you out. Before you get as far as getting the 200, we're going to have checked whether or not you sent the right format of body. And that means that you can write loads of unhappy tests with just this one stub. Because you can try sending data with twos that aren't emails, with subjects, well, we're leaving out the subject. There's loads of unhappy cases you can now test with just the one stub, because by using JSON schema, we've insisted that it matches the appropriate schema. So you can write the test quickly. Okay, we're going to check that we reject an invalid API key. So we set up our client with the invalid API key. And then we say we expect an illegal argument exception when we send an email using that client because it's got the wrong API key. And then we can just assert that the message should be, yeah, we got a 401 saying no token or invalid token. And we can do the same for the invalid email address. So again, this time we'll set up the client with the correct API key, but we'll send an email with an address that isn't an email, which should fail the JSON schema check. So again, we assert that we got the right message back in the exceptions message. Again, we can watch them fail because we're good TDDers and we always watch a test fail first. And we get, yep, rejects invalid API key failed. We expect an exception, but no exception was thrown. We check rejects invalid email address. That also failed. Again, we're expecting exception, but no exception was thrown. And when we go to the code, we can see why immediately. Because when we invoked that, when we sent that request off to the client, we didn't do anything to check what came back. We just expected it was okay. So now, really trivial implementation of some error handling. We can just actually capture the response that gets returned back from the client. And we can require that it's a success, and we can throw an exception. So require throws an illegal argument exception if it misses, and we can throw that message. Now, probably you do much better error handling than this. You wouldn't use a legal argument exception. You might even use return, instead of not use exceptions at all, you might return an either equivalent representing failure. But this is enough to make our tests pass it now. So when we run our test, great, all our tests pass. So that's using WireMock over the wire. But I think the thing that you immediately think about this here is, once you understand http4k and what it's doing, and it has a very simple HTTP model, it's got a request which is just effectively a data class and a response which is a data class. So I'm paying quite a large overhead by running WireMock over the wire here. First of all, I've got to bind to a port, and by the time you're running like 500, 600 tests, binding to port that many times, occasionally it fails. I've never quite worked out why, but occasionally it does, and that's irritating because suddenly you've got slightly flaky build. You're paying all the cost of serializing that data out into ones and zeros, deserializing it back from ones and zeros, putting it back into data classes, and all really for nothing, because you know that you understand http4k pretty well. So let's have a look at whether we can get around that loss, that overhead, by running it totally in memory. So when we newed up our SendGrid email client, we passed it that Apache HTTP client, which obviously only knows how to serialize stuff over the wire. And when we created our SendGrid mock, as you remember, we asked it to bind to a dynamic port. Here it is. So first of all, let's pull that HTTP client out. So instead of newing it up every time, let's just pull it out, because then we can generalize away from always using that HTTP client. So we'll use that new one that we pulled out as a bit of a refactor. And then we can start changing WireMock to operate purely in memory without binding to a port at all. So we do that. We create a server factory, which is a direct call HTTP server factory. And then we can tell WireMock to use that server factory instead of using its default one. So its default server factory is going to run up a server that binds to a port. This is going to give you one which doesn't, just fakes the whole approach. And then we can actually turn that server factory into an http4k handler with some code that I've written. So let's have a look at that code. So we're passing in that server factory. We want back an HTTP handler. I've just, to clarify, because we're converting, I've alias request to HTTP4k request to make it clearer when we are in HTTP4k land and when we're in WireMock land. But because an HTTP handler is literally just a function that takes a request, all we need to do is to take that request and turn it into a WireMock request. And then we can pull out the HTTP server from the server factory. It only ever creates one. And we can call stub request on it, which is essentially its way of getting back a response from WireMock. And that's going to do exactly the same thing as when you called it over the wire. It's going to do all of the same matching logic to find the correct stub, to build the correct response and pass it back as a WireMock response. And then all we need to do is convert that into an HTTP4k response. So obviously there's two big methods in there, which is the one that turns the HTTP4k request into a WireMock request and the WireMock response into an HTTP4k response. Let's first of all look at creating that WireMock request. Well, all it is a class that adapts the one type to the other and implements the WireMock request interface. Again, helpfully, they're both called requests, which isn't very surprising, so hence I've aliased them to make it clearer what's going on. And takes in an HTTP4k request. And then you get 170 lines of really dull code that I'm not going to force you to sit through whilst I click. One of the joys is dealing with endless request and response interfaces, all of them ever so slightly different over the years. And I would love to write the ideal perfect one to replace them all, but it'll just be a case of this. We'll end up with yet another, which will be my one, then I'll have to adapt from my one to everybody else's. Fortunately, the HTTP4k response model is much, much simpler than the WireMock one. So I can actually show you this one totally. All we have to do is create an instance of a memory response, which is an HTTP4k core class, pull the status, convert the status into HTTP4k's status, and then the only real complication is that WireMock keeps its headers as a multi-map, so key to a list of values, whereas HTTP4k keeps it as pairs of key to single value. So all we have to do is flat map, stick it together, and we convert the body just by, it's just a byte array, so we can just pass the byte array straight across, and we have to hard code the version because at the moment WireMock won't let you set that. And at that point, our tests all pass in exactly the same way. Nothing's changed at all. So was it worth it? So we had 10 tests. So in order to find out, I wrote a couple of warm-up ones, which just called the same code to make sure that we'd loaded all the class and the rest of it. And then I copied the tests 10 times each and ran them. Over the wire, it took 84 milliseconds. In memory, took 34 milliseconds. So it was 60% faster, and we lost the overhead of, and we lost the flakiness of needing to do the network binding to a port. So it had value. However, this does raise, I think, a tough question, which is why use WireMock at all? So we just injected that HTTP4k client in anyway. So we could have just mocked it using mock-k, Mockito. We could have written our own fake object that implemented that request. Frankly, it wouldn't be too hard. So what's WireMock bringing to the party if it's not actually listening over the wire? Well, I think the first thing, it was nice that I was talking earlier about how often WireMock is nice because it lets you not have to understand the HTTP client or the library that's calling the HTTP client. It allows them to remain opaque to you because you understand HTTP. So in that situation where you've built up a library of WireMock-based tests, and then you get to the point where you actually do have full confidence in your understanding of the HTTP client, it has the great benefit that you're able to reuse your old over-the-wire tests with minimal rework. Once you've written that adapter, that's going to work for everything. You can now just use that everywhere. You don't need to write a whole bunch of alterations to your tests to use a different mocking mechanism. The second, so I think you may well be aware of the notion of your tests as being like double-entry bookkeeping, that the production code and the test code serve as ways to check up on each other. So I changed the tests with keeping the production code the same to make myself confident that the change to the test is okay. I can change the production code whilst not changing the tests to be confident that the production code change is okay. And I think that gives you more confidence when they're written in different ways of modeling the thing that you're doing. Because the chances that you have a misunderstanding about the APIs of both http4k and WireMock in exactly the same way are pretty low. So I think there's some benefit in just the fact that you're using a different way of doing it. Whereas if you mock out http4k, your miscomprehension of how http4k works might be reflected in both the production code and the test code. But possibly the most useful, I think, is just that you immediately get access to WireMock's ability to do these matches. Now, WireMock can match on literally anything in the incoming request. It can use JSON path or XML path to reach deep into the body of the request to match on bits there. It can match on anything in the headers, anything in the query, anything in the cookies, obviously on the path. It can do so using path template parameters. So you don't have to do a hard-coded path. You can have a matching on something that's going to match dynamically based on regular expressions or a path template pattern. So you've got a lot of power there. And you've also got all the dynamic response templating that WireMock can give you. So again, you can use basically anything in the request in the response. You can, so you don't have to have these totally hard-coded responses. And finally, of course, you've got WireMock's verification APIs. So again, WireMock, you don't need to write your own verifications. You can go, yeah, as you saw there, we verify that a request matching exactly what you're interested in is there, and all that library is there for you already. And then let's say, I don't know how often does I actually do this, but if you did decide that something comes along that means that you'd actually really quite like to switch out your HTTP client, then you can trivially revert it back to the over-the-wire one and check that that change to the HTTP client hasn't changed anything. So you've got that ability to go back. And the other thing is you can periodically make that change just to check that the tests really do work as you'd expect when they're going over the wire, to give you that extra bit of confidence. So that's the case for using WireMock over in memory as a possible alternative way to running it in the traditional way. Just brief plug for WireMock Cloud. WireMock Cloud fills a slightly different space to WireMock. Most WireMock instances live like 1 second. You start them, you prime them, you run your tests, you tear them down. But increasingly, we find that there are people who want to set up a bunch of stubs which are really quite long-lived. They want to fake out some API in a way that people can rely on and be there for a long time. So WireMock Cloud is WireMock in the cloud, software as a service. And it's got a nice UI so that you can see what's going on. And it's also quite a nice way so WireMock open source has a JSON format that it can import its stubs from. So you can write your stubs using the UI if you want to, and then you can export them as JSON. So it's a way to prime yourself up. And if you'd like to have a quick look at the code that I ended up writing to make that http4k implementation work, then it's up there on GitHub, so you can have a play around with it if you'd be interested. Thank you very much.